Hi students, welcome to Earth and Environmental Science and Module 6 on hazards. This is video number 4 and we're going to be focusing for the first of a couple of videos on hazards associated with volcanic activity. The learning intention for this particular video and also the subsequent activities that we'll look at in class are around using secondary sources to investigate and explain the hazards associated with volcanoes. We're going to look at a couple of different sorts of hazards that may be associated with volcanic activity. In this particular video, we're going to concentrate on ash eruptions and lava flows. As usual, we want to try and give you some different levels of success criteria to give you an idea of what sort of things you might need to cover in order to address the particular learning intention of this video. So we'd like you to be able to identify a hazard associated with volcanoes, perhaps specifically contrast ash eruptions and lava flows, just in terms of some sort of comparison between these two in terms of a description of what they are, and potentially to explain several different identified hazards associated with volcanic eruptions, and perhaps link those, which we'll do not just now but in subsequent videos, to the composition and nature of the magma. So volcanoes are another geological hazard. Like earthquakes, there are a range of different types of hazards associated with volcanoes, and these are often associated with the type of volcanic eruption, the nature of the magma, and I guess the concentration of explosive gases that may be present. So when we're talking about some of the hazards associated with volcanic activity, we're talking about ash flows or pyroclastic. So pyro is often associated with the fire, and clastic we know is little bits of rock, so little lumps of rock. So we've talked about conglomerate, for example, as being a kind of clastic rock. So pyroclastic flow is when basically you get these sorts of fire rocks, so rocks that have been heated up so much they're incredibly high temperatures and they get kind of thrown out of the volcano. Ash falls, and obviously you may be aware, well, this particular video is being made early in 2022, and not too long last month, in fact, was when a very significant volcanic eruption occurred around the islands of Tonga. And it was the ash that's actually created a lot of problems, even though there were some other associated things with that volcano, including in Australia we had tsunami warnings that ranged over a day or two just in response to that huge volcanic eruption. Lava flows can be a bit of a problem, and again there's a couple of different types of lava flows. One you can almost walk along the side of, not that I suggest you would, but one that you almost can, and another one which you wouldn't want to be within any distance of whatsoever. One of the kind of hidden or silent hazards associated with volcanic activity is poisonous gas, and there's a number of different types of gases that can emerge as volcanoes erupt, and this can include things like increasing the carbon dioxide and carbon monoxide levels, but can also include sulfur compounds such as sulfur dioxide, sulfur trioxide, or hydrogen sulfide, and that can create that very distinct smell, and it can also lead to acid rain as another side effect of volcanic eruptions. And not in this video, but in the next video, we'll also talk about lahars. So these are all a range of different types of hazards associated with volcanic activity. So let's focus a little bit more on the ash eruptions. So ash is basically associated with these very fine particles. They tend to get into the atmosphere. They can sit for some period of time. We're also conscious of the fact that because of the nature, the explosive nature of some volcanoes, they may move through the troposphere, which is the layer of the atmosphere closest to the Earth, into the stratosphere. And if they go up there, they're going to stay there for some period of time before returning again. It's gravity that settles them, so they're very fine particles. They're obviously associated with a source of heat, and we know that hot stuff rises, and so therefore one of the things that does happen is all these tiny fine particles will be rising up as a result of this very hot center, the volcanic center, but that will then cool as it moves and creates its own kind of massive convection cells. The settling of these fine particles and also the fact that they can move downhill depending on the topography can create great problems. And if you've seen some of the islands around Tonga since the eruption that occurred in January, you would know that one of the things that's most obvious about them is how much ash has actually just completely changed the landscape. How different it looks in the sort of before and after photos as a result of all of this fine sediment settling down. And it gives us a bit of an idea of what we were talking about in the last topic, which is those little ash layers that can be deposited in between our sedimentary layers that are critically important for us in terms of absolute dating. So getting a sense of exactly how that happens when you get volcanic activity and you get these ash eruptions and then ash settles down and it just seems to cover everything. So you get this kind of blanket of ash. The thing with ash is it can travel long distances, and as I'm sure is obvious to you, this kind of thick cloud of sediment has severe, or can at least have severe respiratory implications, apart from the fact that the mere weight of it can sometimes just destroy roofs just by creating too much mass for those roofs to hold. And that, of course, depends on the size of the particles. Now, we're going to have a look at these in a little bit more detail, and I think the eruption of the Tongan volcano is a really good case study for us to look at in terms of evaluating what's going on. That was an underwater volcano, but it had a huge implications on land. The other thing that we will look at in class in a little bit more detail are lava flows. And lava flows are very much linked to the composition of the magma and especially its viscosity. And viscosity is linked to that silica content. And you might remember from our Year 11 studies, we talked about the difference between felsic and mafic magmas and the fact that they were related to the silica content, and that's also going to affect their viscosity, which also means that it'll affect their extrusion rate. That is how fast they are moving away from the volcano, away from the crater of the volcano. Lava can be extremely hot, and it's one of those things you don't necessarily want to be right next to. But there are certainly different types of magma that, when they've erupted as lava from a volcano, move at either very fast pace or a very slow pace, and that can not just be a consequence of the viscosity, but it can also be affected by the slope of the land, and also whether or not it can be contained. Sometimes we find these really nice lava tubes that are associated with particular types of lava flow. And we do want to talk about lava in a little bit more detail when we look at the third of the videos in this series, and that will specifically relate to differences in the composition of the magma and how that can affect the way that the lava flows. Suffice it at this stage to say that hazards that are associated are often linked, and we will talk about this later too, to early warning systems and how early can you give information to people about a potential hazard, a potential disaster that could occur, and is the nature of that eruption, does that give you more time or less time? Is that going to do more damage or less damage in a certain period of time based on the nature of the lava? And so that is something that we will need to come back and have a look at later on. There's a cute little activity. There's lots of these sorts of fun activities, and I'm sure you've all had a go at making your own lava lamp. But lava lamps are one of those nice, easy little simulation exercises for looking at viscosity, looking at eruption, how these particular types of particles hang together, how they flow. And it's a nice, simple little example of how material moves one material through another. And this is an important way to start thinking about volcanoes, especially in terms of the viscosity of the magma and how that manifests once the lava erupts from the crater of the volcano. This is very much an introductory video. We will have a look at a couple more videos on volcanoes and volcanic eruptions, and especially on the composition of the magma, so we can try and understand a little bit more about what's going on in these different types of volcanic eruptions. Thanks for watching.